Welcome to qnawire.
In this problem, I drew a picture to indicate all the pertinent bits of information that are given. So let's start with the object. We're told that the object is at right angles to the optic axis and it's an arrow. And we're given the height of 1.5 millimeters. And we're given S, which is the distance from the object to the vertex of this glass rod, that is 24 centimeters. And we're told that we have paraxial rays that are basically illuminating this object, and it's going to get refracted into this glass. And we're asked to find the image distance, S prime, and the image height, Y prime. So I drew a figure here just to indicate kind of how the image will look, and we can see clearly from these two rays that are being refracted. Well, this one is going straight to the center here, through the center of this glass rod where the radius of curvature is. So it'll go straight through. However, this beam that's coming to the vertex will get diffracted. So then where these two intersect is where my image will form. And we have the index of refraction of glass. We have the radius of curvature. Here we have Na, which is assumed to be air. And now we're going to use equations 34.11 and 12 to find, so from this one we'll find S primed, and from this one we will find Y primed. So let's do that on the next page. So equation 34.11 says that we have Na over S plus Nb over S prime is equal to Nb minus Na over R. And our goal is to find S prime. So let's rearrange this equation by moving Na over S over to the right-hand side, so that we have just Nb over S prime remaining on the left-hand side. Okay, and let's put this whole thing over common denominators. So on this side, let me multiply by S over S, which is nothing more than multiplying by 1. And on this side, let me multiply by R over R, which is also a multiplication by 1. So then I have Nb over S primed is equal to S times Nb minus Na minus R times Na over S times R. And let's just take the reciprocal of these things. So I have S prime over Nb is equal to Sr over S times Nb minus Na minus R Na. And then I'll just multiply both sides by Nb. So then I have S prime is equal to S R Nb, the whole thing divided by S Nb minus Na minus R Na. And we have all of the numbers here that are given to us in this problem. So everything on the right-hand side we know. So let's simply substitute for S. We were given that that's 24 centimeters. We were given R of 4 centimeters, and Nb is 1.6. Again, we substitute for S, 24 centimeters. And then Nb minus Na is 1.6 minus 1, minus R, which is 4 centimeters, and Na, which is just 1. And so when we just compute this, we get 14.77 centimeters. And now we can find the second part by using equation 34.12, which tells us that m magnification is equal to minus NA times S primed over NB times S. So we have a negative NA, which is just 1. S prime we found just now to be 14.77 centimeters. NB, that is 1.6, and S is 24 centimeters. So this gives us minus 0.38. Okay, and also in this very same equation, we have m is equal to y primed over y. Okay, and we can isolate basically y primed, so then y primed is equal to my. So we just now found m, and we found, and we're given y, so y primed is equal to minus 0.38 times 1.5 millimeters, and this gives us minus 0.57 millimeters. And if you just take the magnitude of y, if we just want to know, well, this minus sign just tells us that the image is actually inverted and not erect, right? So if you just want to know how big and you don't care about which direction, then you could just solve for the magnitude of y. But we already know that since m is negative, then the image is inverted.